All right. Good morning, guys. I hope you guys are doing well today. Okay, so today I want to talk about retrieval augmented generation or RAG. Basically, the idea that RAG is changing a little bit nowadays. Right. So basically, let me talk first about the typical RAG setup, which is either you use naive RAG where you do chunking and embeddings and do similarity search, re-ranking and all that, or you use knowledge graph, uh, especially the one that what do you call it, proposed by Microsoft. Both this solution to me is a complex setup and not really to my liking because technically, if you want to use AI to assist you in reading documents, so in terms of maintaining the document itself, it should be quite straightforward, where you have the document and you have AI read it and then assist you with the answer generation, right? It should be as straightforward as that. But instead, because of the token or small token context window last time, that we are kind of forced to use RAG by chunking because we want to make sure that the input token stays low, right? So for knife rack, for knife racks, we need like vector database. Then we need to do ingestion module for, and then in that module we do chunking, embeddings, and then when we do query, there's similarity search and re-ranking and all that. On top of that, we also have to do data management, where from the document, after we do chunking, we upset into the database. And then if we change the document, then we need to delete and upset again, or we do an incremental uh, update to the database. Either way, it's kind of like in my opinion, unnecessary setup for an AI RAG system. Similarly, if you use knowledge graph, it is even more complex because uh, first of all, you need to have or use graph database like Neo4j, which is a lot more complicated than a typical a vector or a SQL database. Then you need to do entity extraction, do relationship, chunking, keyword research and all that. Still, uh, it it's even more complex, right? So, and it's also even stricter data management where if you use knife rack, it is still possible for you to do an incremental updates to the database. But if you use graph rack, then you have to delete and upset again, right? So, and other solution like light rack or hybrid rack is pretty much similar. So it's still still have to employ this complex setup for your rack. Right. So as we know, most knowledge base that we kept in the company, for example, if you have like a policy document or some sort of guidelines and knowledge, uh, not knowledge base, but more like documentation, most of those things are in documents already. They're not in database, but in documents, right? So it doesn't make sense for us, to have that document and then convert into a database, convert into chunks and put it in a database. And then now if we have to maintain those documents as well as the RAG database portion, the ingestion portion of the RAG system, right? So I'm thinking that, to me personally, the best solution if you want to do RAG is that, you know, we just maintain our document as always, as what we do normally, which is, this knowledge base is in documents, so that we also maintain those documents like we do it usually, just update the document and save it, and then have our RAG system to actually read those documents directly as is and answer queries. So no need to introduce like databases and ingestion modules just for uh, document information retrieval, right? So the demo that I'm going to do today, we are going to use Gemini because Gemini LLM by Google has the biggest input context window that you can use, which is I think the Flash 2 is 1 million. Sorry, 1.5 is 1 million. Flash 2 is 2 million. uh, and have uh, and set up the rec in this manner. So basically, we have an individual uh, rec or like bot retriever connected to each of the document that we're going to connect to it. And then when the query from the user uh, reach them, they'll just read the whole document and generate the answer. So that's the idea. And then all the answers will then be curated into one single LLM, and then all the answers to be combined, analyzed, and produce a single uh, answer for the user. So that's the idea, right? So in this setup, to me, it's kind of like a perfect rack because if you look at this, there is no database, no ingestion module, and the setup is a lot simpler, right? And because it can read up to 1 million token input window, the each individual bot here can actually read up to 2,000 pages of document, which is quite a lot. Of course, this is still limited if you have documents that have like really long uh, content, more than 2,000 pages. But in most scenario, this is just enough for any company, in my opinion. All right, so let's look at the codes. Right, so again, I'm just going to do a simple uh, implementation for this. I'm going to use the Gemini 2.0 Flash thinking just to make it more interesting to see, if you use a simple, straightforward LLM like OpenAI GPT-4o, for example, or Gemini 2 Flash, then it's basically a non-reasoner type model. So I'm just thinking, what if we use a thinking model? Would it be any better? I mean, I already tested earlier, and I like it more, you know, compared to a non-thinking LLM. Right. So okay, forget about this because last time I was using Gemini 2.0 Flash, which support JSON mode as an output format. But since I switched to a thinking model, it doesn't allow for JSON mode. So this two actually is not used right now. So let me just comment it out. Right. So let's look at the code. So look at the main first, where the flow of uh, the system works. First, we just put all the rag document into to an array, and then we set up a user prompt for what we're going to ask. Right. So we are going to use async uh, to analyze both of these document at the same time in parallel. It's pretty much similar to promise all method in JavaScript, right? So and when both finish and return, then we're going to look at what kind of analyze what do you call it response from each of the document, sorry, each of the bot, and then we are going to combine both answers into one final bot to actually synthesize both answer into one final answer, and then we're going to look at it, right? So give me right. So let's look at the individual bot. I have the prompt here, so saying that you are an elite researcher with advanced analytical skill. Your expertise is basically to read the whole document, comprehensive document, and synthesize a clear and evidence-based answer. That means it has to be from the document itself. Right. So there is four main tasks I put in this document. So the bot needs to thoroughly analyze. So basically read and understand the whole document, synthesize the information, meaning extract the pertinent information into a concise answer based on the query, and then support the answer with some sort of a reference from a specific part of the document. And then if there's ambiguity, it should say that there's for example, like saying there is no specific um, portion of the answer in the document, but it implies something like that. So the bot will say something like that. Right. So the tone have to be a formal, precise, and clear. And then the instruction is basically read the query and understand the query, what the user wants, and then read the full document. So the document is going to be attached to the contents, right? So and then this is where we inject the query into the final prompt, which is this one, the searchable prompt. All right, so that's basically it. So this will return each of the individual bot here, and then we're going to look at the outcome of that, right? And then both of, I mean, all the responses, I mean, actually the two of them, both of the response will then be fed into the final bot, where it's just, you know, we're just asking to look at the combined responses and then synthesize a final comprehensive answer. So that's the idea lah. So we're going to include the two uh, answers, and then we're just going to like return the final synthesis of the answer to back to the main program, and we're going just going to, like, you know, show it in, just going to print it lah. Right, so let's run this and look at the how it runs. Basically, I'm using Bursa Malaysia documents. One is actually the Security Commission requirements, and another one is a FAQ. So my question is related to the, you know, asking about what is the equity requirement to list your company in Bursa. It's just, you know, something I just you know, plug from the document itself. I don't really give too much of thought into it. Right. So let's let me set up the environment. Okay, then run the main. So we are going to look at the individual response first, and then we're going to look at the final answer. One thing about uh, this technique is, because we are asking the LLM to actually look at the whole document to answer the query, it does take a longer time than the regular RAG. And it's even longer now because I'm even using the thinking model. So not only is just trying to look for the answer, it also thinks about how to answer it, right? Okay, so the answer is now synthesized or generated. So if you look at here, document one from the first document, it basically, you know, saying blah blah blah. See, if you look at it, they say there is no explicit mention of equity requirement, but it just made some inference from some of the content. So saying that, you know, the definition of core business, blah blah blah, given some, you know, some indication of, you know, if this article actually have some info regarding uh, some sort of equity uh, information, right? So say something like that here in page 39. Right, so that will be the first document. And the second document, same query. This document entitled Equity Guideline. This one is a Bursa Security Commission guideline thing. This one is more specific. So it says that depends on the route of. So basically, there's option to answer. So if in chapter 5 part A it says something else, and then some other paragraph also said something about something else. So this one is paragraph 5.02, A and B, and there is also additional equity consideration. So other information. So basically, those two are the synthesis or the answer from individual bot. Now, when we combine this and give it to the final bot, it basically combine the answers and then synthesize the final one. So it says here, based on the document two, say something else, and then document two, or it's used more of document two and only a few reference to document one, because of course document one says that it doesn't have the direct uh, information regarding the query, but it did actually still refer to it. Okay, and then single equity requirement is not explicitly stated, but there is saying that Bursa Malaysia necessitates meeting specific financial benchmark. Blah blah blah. All right. So that's how it is. So I hope you can see how this works. To me personally, I really like this kind of solution because even though it takes longer time, but you know, if you want uh, an accurate answer, then you would expect the generation of the answer to be longer, right? That's what I'm thinking. right? And then another reason why I like this setup, because each of this board actually look at the whole document instead of chunks. Because one of the issue with rag with using a knife rag, especially because uh, when you query and the ingestion module, or more like the retrieval module will retrieve chunks, you might not retrieve the whole, or more like all the chunks that related to the query, because the similarity search basically has some sort of uh, um, statistic based confidence level, with below some confidence level, it is saying that it's not related, so it doesn't retrieve that chunk. So you might lose some details lah when you do knife rag especially. But the good thing about this method is the bot actually look at the whole document. So in that manner, one thing is it might not miss any information regarding that query, right? But again, this is still up to a debate. So, if you guys are interested in this, you might want to test it yourself and see how good it is. To me personally, I rather use this kind of rag system uh, compared to the native and the naive rag, or even especially the graph rag. The one is even I really don't like that. Straight away lah. I just want to say that. Okay, but there definitely has a drawback using this style. Right now it's limited. So the free version, the Flash 2.0, sorry, the Gemini 2.0 Flash free version allows only 15 requests per minute and 1500 requests per day. And also this is still all experimental, so I'm not sure whether they are going to keep this LLM free forever, or they're going to start charging. So that one, we don't know. Hopefully they will keep it this way. So even though with the free 15 requests per minute, 1500 requests per day, if you are using it for internal use only, I mean the rack system for internal use only, I'm pretty sure this is not bad. Even if you even if you subscribe to the paid version, it's really not that expensive. It's about the input pricing is about 10 cent per million token, and then 40 cent USD per million token output. So it's still quite cheap for the kind of capability it's actually showing, which is reading the whole document. So like I said again, the reason I like this because it's a simple rag solution that probably better than a more complicated one with database and ingestion module, blah blah blah. Yeah, even if you want to do graph, then there's even more complex setup. Right. So again, this is my personal opinion. If you guys like it, then probably give it a like. Or if you don't, let's just put it in the comments, and maybe we have a more conversation on this. With that, thank you very much, and peace.